An inclined plane is a simple machine. There are three types of inclined planes: ramps, wedges, and screws. In this activity, we will focus on learning how a ramp works. A ramp is a flat surface used to raise objects. The ramp remains stationary, and the load moves along the ramp, moving up higher and higher into the air. Think about a person lifting a heavy box into a moving truck. The load, or output force, is the weight of the object. We can measure that with a spring scale. The output distance is how high the object is being raised, and we can use a ruler to measure that as well. When pulling something up the ramp, the effort, or input force, is the reading on the spring scale, and the input distance is how far the person has to push the object to get it to a desired height. The ramp can multiply the effort, or input force, so it is easier to lift the object using the ramp than it is lifting it straight up. That's because the ramp holds up some of the weight. In real life, there's friction, so that does complicate things, but typically a ramp is really smooth, and the person will probably push the object on wheels to minimize that friction. In this activity, you will explore how a ramp makes lifting objects easier. The ants will supply the effort, or input force, and the load is the item you are lifting. You can start by finding the minimum number of ants needed to lift the load straight up without using the ramp. The load, or output force, is the weight of the object, and the output distance is the distance off of the ground that the object is lifted. While using the ramp, it should be easier since the ramp holds up part of the weight. The minimum number of ants needed to lift the load is less while using the ramp. That is because the ramp multiplies the input force into a larger output force. In this activity, you will learn the relationship between the length of the ramp, that's the input distance, and the effort, or input force, needed to lift the load. A single ant cannot lift the corn by itself. But when using a ramp, it can. But there's a trade-off. You will learn about that trade-off during this activity. You can make a simple experiment at home that is similar to the simulation you will use in this activity. You just need a rubber band, a ruler, something to make a ramp, something to pull like a car, and a weight to pull. The rubber band will act as the spring scale and measure the effort, or input force. My rubber band has a length of about 2.5 inches without being stretched. The car and weight are the load, also called the output force. Lifting the load stretches the rubber band from 2.5 inches to about 6 inches. But that force only needs to act over a short distance because the load is being lifted straight up. By setting up a ramp and pulling the load up the ramp, the rubber band only stretches about 0.5 inch to 3 inches. That means the effort, or input force, is less. But to raise the load, that smaller force needs to be applied over a longer distance. That's the whole length of the ramp. This is what it means to multiply force. You can use less effort, or input force, to lift the load, because the simple machine multiplies the input force into a larger output force. You will explore this relationship more during the activity.